So today we are starting chapter 3. Yesterday you did the vocab sheet, so you got a good idea of a lot of the vocab that's going to be in this chapter. And a lot of what this chapter is going to be dealing with is parallel and perpendicular lines, and revolving around the properties that come along with parallel and perpendicular lines. So let's look at some of the vocabs or terms that go along with this. Because there's a few that we have: parallel lines, skew lines, and parallel planes. Now, parallel lines you're used to seeing, but the definition was probably a little weird, yes? Because two lines are parallel if or when they do not intersect and are what? Coplanar. Because we're going to define parallel lines as being two or more lines that do not intersect and are coplanar. They lie in the same plane. So to be able to say that two lines are parallel, they have to be coplanar. They have to be in the same plane, and they cannot intersect. Now, two lines are skew if they do not intersect and they are not coplanar. So if two lines do not intersect but are not in the same plane, then we would consider them to be skew. So looking at this here, this line going up and down through the plane and M are skew because they do not intersect, but they are not coplanar. And parallel planes are two or more planes that do not intersect. So if two planes do not intersect, they are considered parallel. Small direct arrows are shown. So we can also use these little red arrows. It's kind of hard to see on your note sheet, but if we use arrows on lines, it's a way to say that they are parallel. So if there's one set, those are parallel. If they do two, those are parallel. So the number of arrows that are drawn corresponds to each other. So if there's three on one line, any other line that has three sets of arrows showing that they're parallel would be matching. Now, we're going to do some naming with this here, and that's what mainly, or a decent part of this first part of the chapter is going to be, is kind of, we'll name some lines, and then we'll deal some more stuff in parallel. But first, let's look at naming a few. So part A, lines parallel to CD and contain point A. So what we want to do is we want to name any line parallel to CD that contains point A. So when we look at the figure, we want to see where's point A on this figure. Well, it's in this top corner. So lines that are parallel, what would be a line that's parallel? AB. And what? It doesn't contain point A. So EF is parallel and is coplanar, but because it doesn't contain point A, we can't include it. So does A and H and A and G, do they intersect plane or intersect the line CD? No, they don't. They don't cross. But are they coplanar to CD? Are they contained in the same plane? Because the plane would be this box here, yes, that extends out indefinitely, is AH and AG in that same plane? Well, no, they go through the plane, yes? So we don't consider them to be parallel. But they would be considered skew. Because a skew line, the lines do not intersect, but they are not contained in the same plane. We call those skew lines. Those would be considered skew. Parallel lines do not intersect and are in the same plane. Skew lines don't intersect and are not in the same plane. So any questions on parallel or skew lines so far? So they're very similar. The main difference between them is that skew isn't in the same plane. Parallel, they have to be in the same plane. And up to this point in Algebra 1, that's all you've talked about. We've only talked about a plane. We've never talked about having more than one, or stuff coming out of the plane. Okay, well, we're still looking at line CD and point A. Lines that are perpendicular to CD and contain point A. So if they're perpendicular, they form a what? Well, the two lines form what when they intersect? Right angle. So what would be a line that makes a right angle with CD and goes through point A? AD. AD would be the only one. And the reason we know it makes a right angle is because, well, the picture showed us a right angle, yes? That's the only way we know it's a right angle is because it was shown to us. Any other questions on anything we've done so far? We good with all of this here so far? Okay. Planes parallel to plane EFG. EFG. So we're mainly talking about this bottom plane here and containing point A. So what plane would be parallel to that bottom plane and contain point A? So we can say plane CDA, plane CVA, or kind of any iteration of those four letters on top, C, D, A, and B. Any combination of those three letters would be a plane that's parallel to EFG and contains point A. Because really, it's just whatever plane is not intersecting it or touching it or crossing it, that plane. So the other four sides, the other four planes that are considered in that cubic or that four-dimensional or three-dimensional shape here wouldn't work because they would all touch the plane. They would all cross it. So the top is the only one that doesn't. The top's the only one that doesn't cross it. Okay, look at the diagram in example 1. Name lines through point F that appear to skew with EH. Skew with EH. So let's see where EH is. EH is right here. Huh? So A and D would be parallel. And are they in the same plane? So for skew, they don't intersect. A and D don't intersect. But they are in the same plane, yes? So that doesn't quite satisfy the definition, but it almost does. A and B, yes. A and B would definitely work. A and B would definitely work. A and C, we would have to make a line that would go through those 2 points. It's not something that's already given to us. D and G would not be, they're not already connected. We're not going to make lines, we're just going to name the ones that are there. Look at the diagram in example 1. Name the lines through point F that appear to skew with this here. Now, AB would work, but since they specified they wanted point F, it doesn't quite work. Because again, it wants names the lines through point F. Name the lines through point F. So FC would work. FG would not because they would be contained in the same plane, yes? Now, if there was a line from F to B, that would work, or F to D, that would work, if there was an actual line drawn. If there was a line given to us, then that would work. But since we're not creating any lines in this figure, we're just naming them, this is the only one that works. So E and F would intersect at point E, and they are in the same plane. Because that bottom plane and the side plane are both contain that line. So we can't have any lines in this plane here or the one below it, because then they would be considered in the plane. Questions on this here? Yes. Yes. So any other questions on this here, how this is working with skew lines and parallel lines? So a lot of this here, really, what you really need to go back to is these definitions. Do they intersect? Are they in the same plane? Intersect? Are they in the same plane? Because if they're parallel, they're not going to intersect, and they're going to be in the same plane. They're going to be in the same plane for them to be parallel. Skew is if they are not. So let's look at another example of this here. So the first one, lines parallel to line GH and containing point F. So parallel to GH and contain point F. FE would work because FG, well, that would intersect. FB would be skew. D what? DC would be parallel. But it's wanting us to contain point F. So DC would technically, if it didn't need that, would be a line parallel to it. But because it wants it to contain point F, it doesn't quite work. But this line would be parallel to it. Well, now it wants a skew line. FB or BF, either one. FG would be intersecting. That's all we could say. Because I don't know anything about how they intersect. I can't say that they're perpendicular because I don't know if they intersect at right angles. It looks like they would, but we cannot assume that they are. I is just a point on that line. And since there's not anything connecting F to I, we can't say that they are connected. Now it's gonna want us to say that these two here are probably perpendicular. I don't like it. Yeah, it's going to want us to say that, but I would want more information in the figure as part of a line. Which lines are parallel in appearance? I would really want this to be determined as a cube or have some more information for this to be true. Because if we know more about the information, then I would say that they're perpendicular. And if you do this on one of my tests, I will have that. I will have the right angles helping you determine if they are right. I don't like that this one is just saying that they are perpendicular because we were not given any information to that. It's just because it's saying that think of each segment in the figure as part of a line. There's nothing saying that the lines have to be intersecting at right angles. So this here is FG, and it's probably going to do the same thing on the homework. But those intersect at a right angle, supposedly. Okay, let's look at the last one. Planes parallel to GHD and contain point F. So GHD and contain point F. Well, that would be what? Plane? Yep, it would be this plane over here, and any three of those four letters in any order would work. Because again, for two planes to be parallel, they do not intersect at any points. They do not cross. What? Because a plane, or a plane postulate, or three-point postulate says through any 3 points we can create a plane. Through any 3 points we can create a plane. It's not 4. It's always 3. It's always... Yeah, so plane AEB, plane AFB, plane AEF, plane EFB. Any 3 of those 4. You can use any 3 of those 4 points. You can't use all 4, but you can use any 3 of them. Does that make sense? Okay. Sweet. 2 distinct lines in the same plane are either parallel or either parallel, like L and N, or intersect in a point like J and N. Through a point, no line. Through a point on a line, there are infinitely many lines. Exactly one of these lines is given to be perpendicular. So through any point on a line, we can draw an infinite number of lines that would intersect it. So through any one line and a point on the line, I can draw an infinite number of lines that would intersect it. There's only going to be one of them that is parallel and perpendicular. So exactly one of these lines is parallel to a given line, and exactly one of them is perpendicular to a given line. For example, line K is the line through P that is perpendicular to L. So what that's really saying is if I drew a line, this isn't going to be in your notes. If we drew a line and a point out here, through this point, there's an infinite number of lines that will go through that point and the line. There's an infinite number because I can draw here, here. And we can keep doing that infinitesimally because there's many, many number of lines that I can draw that will go through that line and the point. However, there's only going to be one line that is parallel to it. And there's only going to be one line that through that point that will be perpendicular. So for any line and a point not on the line, there's only going to be one line that's parallel, and there's only going to be one line that I can draw that is perpendicular. So the parallel postulate, I believe you have down. So if there's a line and a point not on the line, then there's exactly one line through the point, that point parallel to the given line. So in our Euclidean geometry, if we have a line and a point, there's only going to be one line parallel to it through that point. Now, there are other lines that could be parallel to it, but there's only one of them that's going to be through that given point. Now, if there's a line and a point not on the line, so a line and a point, there's only one way I can draw a perpendicular line through that point. Okay? So, given this here, name a pair of parallel lines. Looking at the picture, well, our little arrows tell us parallel, yes? And there's 2 given. One of them is DEM. What would be the other one? Now we draw 2 lines up and down to consider, or to say parallel. So whenever we're saying two lines are parallel, we put the two lines, our symbol for parallel, between them, because that tells us that they are parallel. Any questions on naming parallel lines? Name a pair of perpendicular lines. So perpendicular lines would intersect at a right angle. So if we have a 90-degree marker, they would be perpendicular.
Like CA, like BF word.
I would agree BF would be one of our perpendicular lines. Yes. Now CA doesn't intersect at that right angle. It does intersect where those two meet, but since it doesn't intersect at a right angle, it doesn't tell us that CA and BF or BM intersect at a right angle here. So I'd be looking at these two here. Those don't work. Now, BF or BM and DA or DM, those do because we have that right angle marker. Because it showed us this right angle marker right here. We can say that those two intersect at a right angle. Is FE and AC parallel? FE and AC. No. Because they don't have the arrows. Have the arrows, or we can say something along the lines of them intersecting, because they're going to intersect at some point. They're going to intersect at some point. We could also say that they're not going to be parallel because EF and DM are parallel. And through any one point, how many parallel lines can we have? One. Since they both share M, point M, we can't have two different lines. We use the perpendicular postulate to show that AC is not perpendicular to FB. Well, yes, because again, the perpendicular postulate said what? Through any, so with one line and through any one point, so a line and a point, there can only exist one line that is perpendicular. All right, let's look at this one here. So this, again, this is more of the same stuff. Any questions on any of this so far? Any question on anything we've done so far? So what would be our parallel lines for this here? Yes. Since we have our parallel line markers for these two here, we can say that these are parallel. Now, at this point here, we can't assume that GH or HF or any of those on that line and JL, we can't assume that these two here are parallel because it doesn't tell us that they are. Not at this point, anyways. Now, there's ways that we'll eventually be able to show that those are parallel, but we can't do it at this point. Let's name a pair of perpendicular lines. What would those be? Well, our perpendicular marker is right. JL. JL, JK, either one of those would work. But it's just describing those two lines that are perpendicular, that have that right angle, that make that right angle. Those would be our perpendicular lines. Now, is JN, GN perpendicular to JL? No, because why? They don't intersect at a right angle. And our perpendicular postulate says that for any line and a point not on the line, there's only one line that is perpendicular to it. Well, for the line JL and point G, JK is the only line, GK is the only line that would be perpendicular. So it doesn't work. Questions on this here? Questions on any of this here so far? We good? Okay. Two angles are corresponding angles when they have corresponding positions. For example, 2 and 6 are above or corresponding. Corresponding angles kind of share a similar placement. They're in corresponding areas. So 2 and 6. Well, that's above and to the right. We have above and to the right. So they are corresponding to each other. They line up to each other, yes? So we would consider them corresponding angles. They're in a similar placement to the line and the transversal. Alternate interior angles are between two lines and on opposite sides of the transversal. The transversal is just a line that intersects the two lines. So two alternate interior angles lie between the two lines and on opposite sides of the transversal. Corresponding are on the same side of the transversal and above, both above or both below. So corresponding, they're similar, they're in a similar spot. Transversal, or alternate interior, are in between the lines and on opposite sides. We good with these two here? Because we got two more. Because we have alternate exterior when two angles lie outside the two lines and opposite sides of a transversal, they are alternate exterior. Consecutive interior. They lie between the two lines and on the same side of the transversal. Lie between the two lines and on the same side of the transversal. Alternate exterior, so they're outside and on opposite sides of that transversal, the line that cuts the two lines. Yep. Unfortunately, six feet. Any questions on these two here? Because we're going to start looking at some examples of them. So let's look at this here. Identify all pairs of angles that are corresponding. So corresponding means that they lie on the same side of the line and kind of they match up. So one of them is going to be angle 1 and angle 5. Because as we see here, we can consider this line, this line here to be the transversal. So it's above the transversal and to the left. So I look over here, above and to the left is 5.
What about 2 and 6?
4 and
7. 3 and 7.
3 and 7, below the line and to the left. On the other set of 4, below the line and to the left would be 7. 4 is below the line and to the right. 8 is below the line and to the right. So we're trying to see where they match up. Now, alternate interior. So we're looking between the two lines. We're looking between the two lines. So there's 4 angles between them, yes?
1 and 8.
Interior. So we're looking. So 2, and it wouldn't be 5, it would be 7, because alternate interior. Alternate interior. So alternate is opposite sides. And then we would have 4 and 5. Because we're looking at opposite, alternate, and inside. Because alternate is going to be opposite sides of the transversal and between our two lines. Any questions on these two here? Any questions on how we see these here? Alternate exterior. So exterior would be outside the two lines. So our
1 and 8, 3 and 6.
1 and 8, 3 and 6. Because 1 and 8 are both all outside the two lines. They're not between them. They're outside of them. And they're on opposite sides. They are alternating sides of that transversal. 3 and 6 are the same way. They're on outside the two lines and are on opposite sides of the transversal. So they would be alternate exterior. Right, so consecutive would be on the same side. 2 and 5. And 4 and 7. Because they're going to be on the same side of the transversal in between. Same side of the transversal in between. Now, there's such thing as consecutive exterior angles, which would be 1 and 5 and 3 and 8, because those work also. There's properties to them, but they'd be consecutive exterior. We're not really going to look at those in this one here. So let's look at this one here. So consecutive interior angles is what we're starting off with. 8 and 7, because they're interior, they're between the two lines, and they're on the same side of the transversal, so they would be consecutive interior. And then 3 and 4. Any questions on consecutive interior angles? We good with consecutive interior? So we'll look at them here in a minute. Let's look at alternate exterior. So 1 and what?
6.
Not 1 and 6. 1 and 5. So 1 here. So outside, we would talk about 5 and 6. But for it to be alternate, it needs to be 1 and 5. And then 2 and 6. 1 and 5 and 2 and 6, because they're outside of those two lines and they're on opposite sides of the transversal. Now we'll have a few for corresponding angles, because corresponding angles, again, they match up. They're in similar locations. So we would have angle 1 and angle what? 7, because 1 is above this line and to the right, or left. 7 is above this line and to the left. They're in corresponding spots. Eight and 6, because 8 is above and to the right, 6 is above and to the Yep. So angle 2 and angle 4, and then angle 3 and angle 5. Would be our 4 sets of corresponding angles. Any questions on these here? Any questions on these here? And lastly, alternate interior angles. Alternate interior angles would be what? 8 and 4, 7 and 3. Any questions on any of these here? Any questions on any of these here? Any questions on these alternate exterior angles, alternate interior, corresponding consecutive interior angles? We good with all these here? Yes? Because again, on the homework, it's going to be asking stuff like this here. Classify each pair of angles. So 1 and 5 would be what? They'd be corresponding because they lie in the same spots, don't they? Because we have above and to the right, above and to the right. So they are corresponding angles. Yes. Alternative exterior angles. Because they're outside of the 2 lines and on opposite sides, so they're alternate exterior angles. And last but not least, yes, alternate interior. Now, that's the last page of notes. I think y'all noticed that, yes? Now, you might have noticed, let's go back. You don't have to flip back in your pages or the note sheet. This here, I mentioned the fact that at some point we could possibly say that FH is parallel to JL. At this point here, we cannot, because just looking at the figures, we have no way of saying that these 2 are parallel. There's nothing given to us. There's nothing here telling us that these 2 are parallel. By the end of this chapter, we will be able to say with definitive proof that these 2 are actually parallel. There's a way that we can prove it. And with our alternate interior, alternate exterior corresponding interior angles, we'll be able to use those properties that we're going to learn to show that these 2 are parallel. We're going to be able to show that these 2 are parallel using these properties here. But for now,